Phoebe, how are you? You want to come say hi to Phoebe? You want to come say hi to Phoebe? Just stick your head in.
Hi, Phoebe.
I'm doing quite well. Things are good. I've got a lot of stuff working. This is actually keeping me from being bored, so it's actually a good thing. Although my wife, as you just saw, she's feeling quite bored because she's lost a lot of her cleaning jobs. So she's been here a lot, sleeping more, which she's enjoying, but she feels guilty. But I don't care. She's doing all right. She's enjoying it. Good morning. Good morning. Sign in. Phoebe, are you getting more work from other teachers, or have they been pretty good about not doing anything yet? Good morning, Michelle. Again, good morning, good morning. So very, very little. You know, it's interesting, the stuff that's coming in that we're getting from the district for what's going to happen with quarter 3 grades and quarter 4 grades. Quarter 3 grades have not been put in yet, so I think everything we've done will be good. And so we're sitting very, very good with what we've done for the past couple of weeks, which is great. All right, so we got 4 of us. Let's give it a couple more minutes here, see if there's some more people that come in, and then we'll start doing some questions before we get to the lesson quiz itself. So I'm just eliminating things, getting some other things lined up here. Again, if you're in, please sign in. I see I've got Michelle and Phoebe. How about the other one? Mike. He files his independently. Yeah, he will do his independently as the 1040 short form, I believe. Good morning, Haley. Okay, well, we're underway, so if we've only got 4 or 5 again, if you come on in, boy, go ahead and sign in, everybody, real quick. That's great. This way I've at least got kind of an idea as to how things are going for people, or at least who's coming. I know we didn't get a big turnout yesterday. We were under 10. That's the first time that happened overall. I'm assuming that's going to pick up once we get to second quarter as well, or the next quarter. Good morning, Remini. Okay, well, let's take a look at questions that we've got from the day 2 assignment. So if you've got a question on something you want me to take a look at, let's go ahead and do it. We'll work through as many of those, and then we can go ahead and get to some details on the quiz. So here we go. Number 37. Okay. All right, so here we got an angle of elevation. So give me a little bit of time to get a picture drawn here as I'm kind of reading it. So we've got a 10 telephone pole that's casting a 17-meter shadow down a slope. Okay, so my beautiful slope, I've got a 10-meter pole. And again, this isn't going to be drawn perfectly by any means. Okay. And so in this, they're giving us kind of the whole picture here. Is they're saying the slope is 17 degrees. Now I've drawn this probably a little bit steeper. And what can get confusing here is all of the different pieces of information here. So I'm going to try to color code here all of the different pieces of information. And so then it's saying we get the 17-meter shadow. Okay, so that's 17 meters. So the shadow is kind of going right along here. So I'm going to try to make that. I don't know if you can tell the difference in colors. But they're saying that's 17 meters there. And then the angle of elevation of the sun is 42 degrees. So this shadow that they're arguing here, that they're stating, they're saying that this whole thing right here is 42 degrees. So you'll notice that they've marked in the picture here, oop, this is not 17 degrees. They are marking that as an angle we don't know. Okay. So let me change colors here so we've got things kind of working here. So this is theta. And you'll notice that in the drawing that they are marking the angle inside the triangle. I'm going to mark it on the outside here just because I'm running out of room here. But they're marking that as 42 minus theta. And again, all they're doing is they're taking the entire 42 degrees, subtracting the angle of the ground to get the angle on the inside. Okay? All right. Now, in this particular case, it says find the angle of elevation to the ground. So in other words, they're asking us in this problem is to find theta. Okay, they want us to find theta. So what I've got to look at here is, again, it's not going to be so much doing the law of sines here. It's going to be getting the correct information to apply the law of sines. Now, as I look at this, what I've got to do is I've got to look at my picture and determine what kind of information can I gather from the picture that I have. Now, what throws people off, or maybe the start of this problem, is again, I need something that gives me an angle and a side opposite for the law of sines to work. Well, it's nice because I've got the 10 meters, which gets me to this angle. So those two can match up here. The problem is it's not a guaranteed angle because it's got theta in it. So I've got to look at this picture a little bit differently and figure out another angle. Now, since I don't know the angle here, it's not going to allow me to get the angle in this corner. But if I think a little outside of the box, let's say, I don't know if this color is going to work or not. What if I were to bring this down right here and form a 90-degree angle? Now, my process here is understanding that they gave me the angle of elevation up to the sun. So this angle, looking at this big right triangle here, that's 42 degrees. So think about how that would allow us to get the angle up here. Since this is a right triangle, the angles in a triangle have to add up to 180 degrees. Well, 90 degrees is taken up right here, which means that the other two angles would have to add to 90 degrees as well. So let's say for a moment, I just call this phi. Phi would then be equal to 90 minus the 42 degrees, okay, the angle of elevation that I was given to the sun, so we're looking at 48 degrees. So from here, now since I know that phi, or that angle up here, is now 48 degrees, now I can utilize my law of sines because I have an angle, reference value, and its opposite side. So since I'm going to be looking for an angle here in the end of it, I'm going to keep that in my numerator. So as I set up my law of sines here, I can say the following. The sine of 48 degrees divided by the opposite side of 17 will then be equal to the sine of that quantity, 42 minus theta, divided by 10. Okay? So now as I work this, I'm going to go ahead and try to solve for that theta. Okay? So as I do that, I'm going to go ahead and multiply by 10 and then take the inverse sine. So I'm going to do two things at once. Multiply by 10 and then inverse sine will give me the following. So I'll have the inverse sine of this whole thing that I'm going to have here. Now keep in mind, this is happening after multiplying by 10. So 10 sine of 48 degrees divided by 17, and that will be equal to 42 minus theta. Okay? So then from here, to get theta, I'm just going to start doing the simple math that would come from this. So the final result here, I'll move to this side so I'm not covering my work here. I'm going to subtract 42 from both sides. So that would give me the inverse sine of the sine, 10 sine of 48 degrees divided by 17. But then I would subtract 42, and that would be equal to negative theta. So now the last thing, switch your signs. So when I switch the signs here, I'm essentially swapping the spots. The 42 will be positive, the inverse sine portion will be negative. So finally, I'll get to say that theta would be equal to 42 minus the inverse sine of the 10 sine of 48, all divided by 17. And then from there, you should be able to calculate it. Okay? So give me a thumbs up if that makes sense, Phoebe. As you do that, I'm going to calculate it here. Let's see what we get. Okay, so let me know if you're on track with that. I'm going to get this calculated. Let's see what we come up with. So I'm getting 42 minus second sine. Let's do a fraction. 10 sine 48. Okay. So again, if I'm using my iPad calculator, again, I don't know if this is going to come in or if I can get it to focus here. Okay, I don't know if it's coming in, but hopefully you can kind of get the idea here. I come up with 16 degrees. Okay, so I'm assuming 16 is the correct answer here. Let's take a look real quick. And we're looking at 37. I get 16.1. So they rounded it to one decimal place. And yeah, 16.078. So, okay. We're good there? All right, other questions? $41. All right. Okay, so in 41, okay, so we've got a pilot has just started the glide path for a landing at an airport with a runway length of 9,000 feet. Okay, so I've got a runway that I'm guaranteed is 9,000 feet. Okay, so I'm going to label B for the beginning of the runway and E for the end of the runway. Okay, just to give them a beginning and an end. Okay, so in this case, it says the angles of depression from the plane to the ends of the runway. They give us the two different angles. Okay, so you'll notice obviously one's bigger than the other. Now I'm gonna make this a little bit. It's not going to be as narrow as what it would be. Okay, but you're going to have something like this. So up here is going to be my plane. Again, not perfect by any means, but hopefully gives us the right idea. Now, what we have to keep in mind here is that they're giving us the angles of, got to make sure I'm reading it right, the angles of depression from the plane. So I'm looking at it based on a horizontal from here. Now, I'll try to color code these again. So let me use, I know green is doing okay. And let's use a blue as well. Well, let's go red and blue. Okay, so when we think about this, the bigger angle, when I do the angle of depression, the bigger angle coming from the horizontal would have to go to the beginning of the runway. So that's going to be, in this case, the 18.8 degrees. Okay? Then the 17.5 will be the smaller angle of depression. So that's going to be the angle of depression looking at the end of the runway. Okay? So I'm assuming that's okay here. So in this particular case then, so the first thing they want is the diagram. So this is what we're looking at for this part. Now, from here it says, find the air distance the plane must travel until touching down to the near end of the runway. So that would be the beginning. Okay, so if I want to change, let's say we call it the near end of the runway. Let's say letter N. Okay. Now, what they're asking for then is they're essentially asking to find this distance here. Okay. So that first part B, they're looking for this distance right here. So, in order to do so, again, this isn't going to be so much about the use of the law of sines, but getting the correct information we need for it. So when I take a look at my triangle, these two angles of depression become very important, because what I need from that is the angle in between them. So I'm needing this angle here. Well, notice the two angles of depression can give us this by a subtraction. So what I'm getting my angle here in green, I can do by doing 18.8 minus the 17.5. And so in that case, I'm looking at, what do we got, 0.3, we got 1.3 degrees. So very, very small window here, which would say that this plane is quite a ways off yet. Okay, so now what that's telling me is I've got at least a reference angle here and an opposite side. But now what I have to keep in mind, I'm still needing to get the information in order to apply the law of sines. Well, if I'm looking at getting this distance here, I'm going to need its opposite angle as well. Now, here's where we look back to geometry here a little bit. Think of that Z shape in geometry. Now, this is assuming that since the angle of elevation is done from a horizontal, the assumption here is that the runway is also horizontal. So what that's telling us is that we have that Z shape, okay, which if we think of that from the idea of parallel lines and a transversal, okay, essentially that Z shape is what I'm looking for here. So when I have this angle here, okay, which is representing the 17.5 degree angle, it's going to match the interior angle as well. Now, another way to think about that is that the angle of depression from one object to the other object, the angle of depression, horizontal down, is the same as if you take the angle of elevation from the other object back up. So what that's telling us here is that the angle down at the end of the runway is also going to be 17.5 degrees. Now we have our information that will allow us to get side D. So again, I'm going to stay with, since I'm looking for a side here, in this case, then I'm going to say that 9,000 over the sine of the 1.3 degrees will be equal to the distance to the beginning or the near end of the runway divided by the sine of 17.5. So notice that the distance then is very quickly calculated, multiplication by the sine of 17.5. So we would have the distance being 9,000 times the sine of 17.5 degrees, all divided by the sine of 1.3 degrees. Okay, so when you calculate that, then you'll have that first value. So give me a thumbs up if that's going well, and then we'll continue from here. So let's make sure that that's right. I'm going to need that for part C. So let me know a thumbs up. I'm going to calculate here real quick. Okay, so I'm going to take it to the nearest foot here because a little bit of a foot isn't going to be that far when we're talking about almost 120,000 feet here. Okay, so we're good there. So then looking at the second, or part C, it says find the ground distance the plane must travel until touching down. So now what I've got to do is I've got to look at my picture a little bit differently here. So I'm going to need this value. And so what I'm going to do is I'm just going to draw another picture here. I know I'm going to start running out of room on my board here. But on part B, or on part C, excuse me, what we're looking at then, if my plane is right here, we have just calculated the distance to the near end of the runway, and we said this is 119,289 feet. Okay, so we've got that, but what they're wanting now is that ground distance. So in other words, what we need to be looking at, I'm going to try to highlight it here in blue if that makes sense. We're essentially looking for this ground distance. Now the thing to keep in mind is that what I'm forming then is a 90-degree angle here. And so if I'm looking for this distance here, okay, let's say I call that, let's call it G for ground distance. Okay, you'll notice that this is going to generate a right triangle. But now what I have to keep in mind is I still need an angle from that. And so again, if I look at that idea of the angle of depression, that going to the near end of the runway was 18.8 degrees, I can use that Z shape here to come down and say that this is 18.8 degrees. So notice, then if I look at my triangle here, I have a hypotenuse, I have the side that I'm missing, and I have an angle. So that will be that's a setup, when I look at just that information here, would be a setup for cosine. So I could argue out of that from this piece alone, that the cosine of the 18.8 degrees would be equal to G over that 119,289. And then I can calculate my value of G from there. Okay? Because it's just going to be that 119,289 times the cosine of 18.8. Okay? Then in part D, then it says find the altitude. Well, if you're looking for the altitude, let's just say I call that an H, altitude is height. Notice that you can use sine, and you'll finish it from there. Okay? Is that enough to get you going on it? Make sense? Give me a thumbs up on that part as well, Michelle. Okay. Now, the only thing that I'd maybe be considering is that they might change the unit of measurement, because these are large numbers, so they might change that to miles. Okay, so just keep that in mind as you do that, as you look at the answers. I'm not looking at them right now, but if we change those to miles, it would be a little bit more, maybe a little bit more realistic here. Okay, because we can't really picture 119,289. Okay. That turns out to be about 22.6 miles. Okay, so they might do that. So just keep that in mind. Okay, so other questions we want to take a look at? So I'm taking things went pretty well for this assignment then. If you can give me I'm not seeing anything else coming in here, so let's give a smiley face if we're feeling pretty good about the assignment the way it is, and then we'll go from there. There's only 6 of you in the room, so we're not getting a very large turnout at this point, but okay, so pretty straightforward, I'm taking it. I got 2 that have come in. There we go, there's 3, there's 4. Good morning, Episo. I did not know you were here. Okay? Keep them coming if we got them. I'll do one final call. Things are looking pretty good, though. Oh, there we go. Problem 43. Okay, let's look at 43. Okay, so this one's going to be somewhat similar to the airplane problem, is that we've got a boat is sailing due east parallel to the shoreline at a speed of 10 miles an hour. Okay, so it's traveling along a parallel here. At 10 miles an hour. Okay, so in this one, it says at a given time, the bearing to a lighthouse. So they're giving a lighthouse somewhere down here. So let's say I call that L. So they're giving a bearing to the lighthouse. So in other words, they're looking at kind of a line to the lighthouse here. And they're giving it as a bearing of south 70 degrees east. So what that means is that I'm starting by facing south, and then we're rotating 70 degrees to the east. Okay, so that's giving me a 70-degree angle there. Now, 15 minutes later, so I got to keep in mind I'm traveling 10 miles an hour for 15 minutes. He takes a second bearing. In this case, now it's south 63 degrees. Okay? So from here, then it says the lighthouse is located at the shoreline. What is the distance from the boat to the shoreline? Now they're showing, like if I were to use these verticals here, what they're essentially doing is they're saying, okay, they're looking for this distance. They're putting on the left-hand side of the picture here. Now that's okay. So we're essentially going to be looking for somewhere in here that 90-degree angle here to find that distance. Okay? So what I need to find in this, and again, it's not going to be so much applying the law of sines here, it's getting the correct information in order to use the law of sines. So one thing that I want to recognize from this picture is that if I'm going to be looking for this distance, the way I'm going to get it in this right triangle is if I can find, let's call this point B, let's call this point A. If I can find this side right here, then I can use cosine in order to figure out this distance, okay? So if I was looking at this, let's say in terms of the lesson quizzes that we're going to have, these are the kinds of things I would need to explain. Is that in order to get to this distance, I'm first going to need to find my length of B here. I'm going to find my length of B using the law of sines somehow. So the question is how do I apply it? Well, here's where I go. Again, it's all about getting the right information to get the pieces of information that you need to use the law of sines. Okay? So I need to get this side, which means I'm going to need its opposite angle. All right? So if I need its opposite angle, I already know that we've got 63 degrees here. I've got another 90 degrees that I've made because of the bearing starting on the facing of south. So we would be able to say that this whole angle then would be 153 degrees by adding. So notice that gets me set for these two pieces. But now for the law of sines to work, I still don't have my reference information. I'll use this to get B, but I need reference information. I'm still going to need a side and its opposite angle that are guaranteed values. Well, that's going to come from finding this side, which I can get from this information. Okay? Since the boat has traveled 10 miles an hour for 15 minutes, let's do a little math, shall we? Now you'll notice that it's saying miles per hour. So let's think about 15 minutes in terms of hours. That would be 1/4. So my distance here that I could say, I don't know, let's just call it L. Let's call it little l, okay? Using the opposite leg here. Opposite leg, opposite angle. If I call that L, I can calculate L by taking 10 miles an hour and multiply it by the 15 minutes, but keep in mind, minutes, I need to convert. 1/4. So I could say 0.25 hours in this case, just to not to mess up a whole bunch of fraction stuff. So again, that'll allow me to calculate. So in this case, if I do 10 times 0.5, or excuse me, 0.25, I'm hoping that you would agree is 2.5 miles. Okay? So we've got that as 2.5. All right? So then from here, this is going to be my reference side. Well, I'm still going to need the reference angle down here. Well, I think we've got enough to get there. Since I have the bearing of 70 degrees over here, I can find the angle on the inside of that triangle by subtracting from 90. That will be 20 degrees. So from here, now I've got the 20 degree angle here. I've got 153 that I found there. 20, 153, that's 173. In the triangle, have to add up to 180. So we can argue or conclude that the angle here is 7 degrees. Now we have our law of sines that we can apply. So think about your pattern. Law of sines to get B, cosine of the angle to get D. Okay? So as we do that, 2 steps. Okay? So let's get the law of sines done. So in this case, I'm going to set up my reference here. I'm looking for a side, so I'm going to put my side values on top, 2.5 over the sine of 7. That's going to be equal to B divided by the sine of 153 degrees. Therefore, we can argue that B is equal to 2.5 times the sine of 7 degrees, or excuse me, times the sine of, not 7 degrees, 135 or 153, divided by the sine of 7. All right? So then from there, I can use cosine to finish here. So I would be able to say that the cosine of my 70 degrees is then equal to B divided by, or excuse me, D divided by B. That was not very good letter choice, was it? Okay. So notice that in this case, to get D, the distance that I need from shore, is just going to be the value of B that I find from here times the cosine of 70 degrees. So you're just going to take this value, sub it in, and multiply. All right? Give me a thumbs up if that makes sense. Okay. All right. Any other problems? One final call. Any other problems that we want to take a look at? Okay, I'm assuming everything's going well here then at this point in time. Okay, so your lesson quiz now is going to be like a miniature write-up. So this would be a really good problem to kind of use as a jumping point here for us to understand how we're going to want to do this. So what you're going to be getting here, now you're all, the 7 of you or 8 of you that are in the room here, you are all getting essentially the strategy or the process to make sure you get through these problems. So you'll notice that you know, as we worked this problem, I'm going to use this as the example. The first thing that I want to do is I want to make sure that I can get my answers. Okay? So before I even start thinking about what I want to say in terms of writing, I just want to work the problem out. I want to make sure that I understand I can get my answers that I need. Okay? So do that all in a, pull out a separate sheet of paper, notebook, whatever you want, and just crank out the math. Okay? Now the purpose of that is so that you're doing all of the math first, and that's helping you to get an understanding of what you need to say. Now, keep in mind that in this particular problem, our goal was to find this distance. So we need to look at concept and context as we do that. So the context is finding this side, finding this distance right here. So the context is to find that distance. How am I going to do that? Well, I'm going to find that by first finding this side. So think about the explanation that I'm making here. My goal is then to find this side. I can do that by the law of sines, but I need to make sure I explain how did I get this angle, how did I get this angle, and how I got that angle. So there's explanation in context where these are coming from. So think in context. Since I was given the bearing of 70 degrees, or south 70 degrees east, the angle inside my triangle I can get by subtracting, and I get my 20 degrees. So I don't need to actually show that. Most people, I'm understanding, we're just going to subtract it from 90, get 20. Over here, I would also then explain, I'm given the bearing south 63 degrees to the east. I'm forming a 90 degree angle here. I can add those to create the 153. So I can then find the third angle by subtracting those two values from 180. Then I'm going to go and explain I need to calculate this distance by just doing a little calculation of distance, or excuse me, rate times time. And I come up with 2.5. And I'm going to want to show my setups to that. So I make my little explanation, then show the work under it. Okay, so you don't have to explain, now I got to multiply by this, and now I got to divide by that. You don't have to do that, okay? Because that's going to come in your explanation. Okay, so think about your getting through it. Now you've got your pieces, so from here I can apply the law of sines. Then show your work. From there, then you can make the next step and say, now, since I have that distance to the lighthouse, I can now apply cosine to figure out the distance I need, show the work, get your answer, and make sure it's labeled. Okay? So again, your strategy here is the first thing you do before anything else. Just work the problem out and make sure you can get to the answer you need, but then think about your process as to how you're going to get there. Okay? So again, the more concise and the more precise your description is, the better your chances of getting that 4. Okay? All right, so you will see when you go take a look at the quiz, that if you just do the problem and you do no explanation, the best that you can get is a 2.25. So I know that those that are in the room here, you now have your strategy in front of you, so you're a little heads up to those who have chosen not to come see us. Okay, so from there, we feeling pretty good? If we are, give me another smiley face. Let me know that we're good to go, and we'll take it on to the quiz. Okay, there's one. Uh-oh. Did I put everybody to sleep? Did I put everybody to sleep? Are you there? Are you there? Okay, there we are. Now they're coming in. Okay. All right, so from there, everybody, the quiz is posted. I've got it posted that it will be, basically I'm giving you about an hour. So at 11 a.m. will be considered the close of it. And then I will make sure that all of that information will transfer into quarter 4 grade, and we will make sure that you're getting credit for it there. Okay, so from here, everybody, have a great afternoon. And then tomorrow, the only thing that we'll do for the live feed is we'll just go over the quiz real quick. Okay, so I'll actually do a full write-up on the board with you here for the problem that you're given, or at least get through the explanation of things. My goal is to have everything corrected tomorrow morning. Okay, so have a great day, everybody. Maybe get out if you can. Enjoy the sun that we've got today. I don't know if it's windy. Doesn't look real windy. Get out and enjoy. Get a little exercise as well. Have a great day. We'll see you all tomorrow. Stay healthy. Take care.